Wow! You must spend a few minutes to watch this demo I've discovered. What's the most difficult part of manufacturing a new photonic system or sensor? Most companies employ brilliant optical engineers who can take all the application parameters and deliver a plan. That's usually not a problem. But the challenge now for the supply chain manager is to turn the fully spec design into an accurately costed fabrication plan. But working out the cost of manufacturing a new optical device is often time-consuming. It requires designers to negotiate with fabrication specialists, and there could be costly human mistakes. But watch this. Because in beautiful St Gallen in Switzerland, there is a small office manned by brilliant optical specialists busy with a much smarter system to calculate all the costs of your new design. Let's bring up the line to Oliver Fangle, CEO of PanDao. Okay, Oliver, let's assume we have designed an optical system. Show us how your software works out the cost of manufacturing and allows us to see the financial impact of possible component tweaks.
And what we developed after 30 years of experience and pain at this interface is a software that is capable of reading in the optical elements due to a standard and spit out the fabrication chain in terms of technologies needed and optimized for minimum cost. So it tells you how much will this design cost in fabrication. And with this, you can put your screwdriver in the tolerances digitally and go up and down and see price goes up and down. And this is for designers very nice because they don't need to ask people like me, is this possible and how much would it be if I would have double tolerances or something? They simply can do it by themselves. This software reads in an optics element description due to ISO 10110, and we also need to know how many lenses you want to produce. So I show you live in the internet in a second. So you need to tell us the design of this optical element, the technical drawing. We can start. And with this, it's very easy. It's all 10110 ISO specifications. And of course, you need to have, just that your eyes get acquainted, you need a lens diameter and a center thickness, and you have two sides. And you can choose a lot of materials from glasses to tungsten carbide to all types of plastics, a few silica. And of course, you can also use flat spheres, cylinders, A-spheres, and so on. But just to show you how it's working, let's go for a very simple biconvex lens, spherical one. Both sides are spherical one, and it's 50 millimeter diameter. You want to produce 5,000 pieces, and then you run the program and you see this lens costs you $17. And that is the cheapest fabrication chain. And if you move your mouse here, you have a literature data bank explaining those names that are needed. And you also see the fastest chain, in this case, precision glass molding. It's more expensive, but it's faster, and sometimes time matters. This takes 1 day to produce one batch to deliver, and this is only half day, so it's double speed. And we also give you the best centering technology. In this case, it costs €1. And of course, the testing cost along the fabrication chain, the handover cost between the polishing department and the grinding department, not the final compliance test. That's how it's working. You can also play around as optics designer to have more fun. Let's go for an A-sphere. This is an aspherical lens, 220 millimeters diameter. And if we want to produce this, then you see it's wheel polishing. Here you get explanation what wheel polishing means. Now, the shape accuracy is 2 fringe irregularity. If we go now for a 5th lambda, and if you go for a 5th lambda, then you see something happening. MRF polishing is moving in and price goes up just a little bit, but it's working. And then we build out of this a 10th lambda without any discussion with any fabrication department. During the design, hit the button and you see if I want a 10th lambda, A-sphere, then bonnet polishing and iron beam figuring is the best choice, and it will cost you $200. So this is the fun. And how can you optimize the chain? I show you. If you have one aspherical lens with a certain shape accuracy, then you change the shape accuracy as you just have seen, and you see the price changes. And you can play this game with all parameters existing. You can also do some more complex stuff. Like these are two designs. They both have the same task. This is all spherical ones, two pieces. This is one aspherical lens that does the same. So the question is, can I go for the A-sphere or should I produce the two spheres? And with PanDao, you can calculate, and yes, the A-sphere costs you $30 and the two aspherical lenses cost you $18. But adding material cost information, you see that you can save 50,000 euros if you go for the A-sphere, and you can dare doing so because PanDao tells you it's safe, production is working. Another example is you see on your mobile phone the technologies needed for the lens. So this helps purchasing managers to negotiate somewhere in Asia on site and see what is the actual cost. My negotiating partner is knowing and he's talking price. This helps you during negotiations. And there are other customers of us who are doing, they call that product life cycle. Every single data point here costs people, let's say, 2 to 3 days calculating. And here you have that with one click. You see technology change from CNC full aperture polishing to precision glass molding when you start producing 10,000s. So if you are here and you want to put an order, you better put an order for 2 years because then it's half price. There are 340 different technologies or tricks to generate an optic. And we found a way to digitalize, to meteorologically analyze this, to make a print of them and to make them compete with each other. So there are 340 horses which start running. And the best chain, from rough, medium, and then top quality chain, the best chain, everybody of these horses wants to be in the best chain.
Oliver, I have never seen anything like this. Attention, Optica corporate members. If this demo spoke to you, then we have arranged for you to get a custom demo from Oliver, plus some exclusive benefits I can't share publicly. So to qualify for some major first mover advantages, just drop me an email and we will set things up. Finally, Oliver, you have to tell us how you came up with that name.
When I was a child, I loved a Czech children's series. Today it would be a season in Netflix. That was called PanDao, a small puppet, a magician, and he helped a boy to survive in school. And it was in the 80s and the 70s, okay? And I loved it. And Pan means Mr. in the Czech language. And Tao was the name of this magician who helped this boy to survive in school. And I thought, PanDao. Dao is an oracle, like Delphi in Greece, okay? So Mr. Oracle, because it's the first time you can watch in this glass sphere, the oracle, how should fabrication be done for this lens? So it's Mr. Oracle.
Wow, have you ever seen anything like PanDao? Definitely not.